Hi, I'm Massimo Banzi and I like to make stuff. Welcome to another tutorial taken from our Arduino Starter Kit. So today we're going to be building a small musical instrument. You can see here it's again a simple circuit. We have 4 buttons connected to the Arduino and a small piezo speaker or piezo speaker, depending on where you come from. So let's press the buttons and see what happens. So each button is associated with a note. So every time I press a button, Arduino produces a sound through the piezo speaker. So how does this work? Well, let's start from the circuit. You can see here there are 4 buttons, but the 4 buttons are connected to the Arduino board with just one wire. So in the previous examples, we've seen that for every button, we had a wire going to the Arduino board. We were using one digital pin to read each individual button. In here, we have 4 buttons connected to just one wire because we have built what is called a resistor ladder. So there's a combination of resistors and buttons. When I press one of the buttons, I create a combination of resistors that let the current flow through them, but then the voltage that the Arduino board measures out of this resistor ladder changes depending on which button I press. So each combination of buttons produces a different voltage. And you know that voltage applied to an analog input can be read from the Arduino using analog read, and then using a series of if statements, we can actually say, okay, if the value is between this number and this number, I press the first button. If it is between another set of numbers, I've pressed the second button. And I can experimentally figure out which one are the buttons that I've pressed by looking at all the numbers that come out when I press the different buttons that correspond to the combinations of resistors. Now, the output of this circuit, the actuator, is this piezo speaker. The piezo speaker is a very simple device made of piezoelectric material that has this feature that whenever you power it with electricity, it will make a small click. If you turn on and off the power to the piezo speaker at a certain speed, this sequence of clicks make a sound. So for example, if I turn on and off the power 440 times per second, I produce a sound which is a very well-defined note. So in our code, as we will see in a few minutes, we have defined all the different frequencies of each note. And when you press the button, the Arduino detects which button has been pressed and then plays that particular note on the speaker. So now let's have a look at the code and let's read it line by line to understand exactly how to implement this behavior. Let's start from the beginning. You can see on this line that we are defining a new type of variable called an array. So this is a variable called notes that contains 4 different integer values. Each one of these integer value represents the frequency associated to a certain note. In particular, these are the middle C, D, E, and F notes. This will be useful later. When we detect which button has been pressed, we can then choose the right frequency to play on the speaker. Then we have the usual setup where we have a serial begin to begin a communication with the computer. So let's look at the loop now. The first thing we do, we create a variable called sounder that contains the value read from the analog input 0. That represents the combination of keys that have been pressed on the keyboard. Then we print that value on the serial monitor so that we can look at it on the computer. And then we start to understand which button has been pressed. So we do this by looking at the sounder variable using a set of if and else if statements to segment the value in different bands and which figure out in which band the value falls, and each one of them corresponds to a sound. So at the beginning, when the value is 1023, then we know that we have to play the middle C. We are using a new function called tone. Tone is able to produce a sound on a small speaker or piezo speaker connected to a certain pin on the Arduino. The only thing we need to do is we need to say this is the pin where the speaker is connected to, in our case number 8, and then we have to specify the note. and that note will be played on that pin. Then, if we continue down the source code, you can see that there's a number of else-if statements that divide the value of sounder in different bands. So we have a band that goes between 920 and 1010, that corresponds to the middle D, a band that goes between 505 and 515 that corresponds to the middle E, and finally, a band that goes between 5 and 10 that represent the middle F. If none of this combination is actually detected, then there's a final else statement that you can see here. This else statement calls this function called noTone that stops any sound being produced on a specific pin. So we say noTone 8, and this stops the sound. So let's try again the instrument and see how our software is actually working here. In the same time, I will open my serial monitor so that we can see the numbers while I press the button. So at the moment, we see a value which is very close to 0, which represents the fact that no button has been pressed. So we press a button, and we get 1023. The second button is 1002. The third button is about 512 or something. And the last one is kind of in that sort of 15, 20 sort of value. So this is, in a very simple way, a small musical instrument that you can build very quickly with your Arduino, a piezo speaker, a few resistors, and a few buttons. So this is all for now, but remember, build it, hack it, share it, because Arduino is you.